Okay, so let's find the directional derivative of our function at the given point in the direction of the vector v. So our multivariable function f of xy is 7e to the x times sine of y. The point is 0, comma pi over 3, and the vector is negative 3, comma 4. So in order to find the directional derivative, we need to know the gradient and then dot product that with the unit vector. Now this is probably not our unit vector, it's just a vector v. So we have to figure that out. So let's do that. But we'll first find the gradient because I feel like that's more challenging. So basically we just compose all of the partial derivatives. So remember the partial derivative with respect to x is treating y as a constant. So it's 7 sine y e to the x. And then treating x as a constant, we have 7 e to the x cosine y times 1, but it's the same thing, 7 e to the x cosine y. So just to find the gradient, we have 7 sine y e to the x, comma 7 e to the x cosine y. I think I'll write the e to the x first just to be orderly. Okay, so let's see here. We have to first figure out the gradient at the point. So let's do that. The gradient at 0, comma pi over 3. Which gets you to 7e to the 0 times sine pi over 3, comma 7e to the 0 times cosine pi over 3. So just to finish stuff up, we have 7 times 1 times root 3 over 2. So it's 7 root 3 over 2. This is 7 times 1 times 1/2, 7/2. That's the gradient, but we have to continue to find our unit vector. It's not given to us like it was in some previous problems. We have to find it. The unit vector is just going to be, so first of all, let's take the magnitude of this and make sure it's not a unit vector. So the square root 9 plus 16 is 5. That's not equal to 1. So it's not a unit vector. So just to figure out what our unit vector is going to be, just take our vector v and divide it by its magnitude. The vector v is of course negative 3, 4. The magnitude is of course 5 because we just figured that out. That's negative 3/5, comma 4/5. So that's our vector u, unit vector. So just to put everything together and find the directional derivative in the direction of the vector v, this is still in the direction of the vector v, it's just doesn't have the same magnitude as v, that's it. It has a magnitude of 1 instead of a magnitude of 5, basically. So we just divided by 5. It's very, very intuitive. So directional derivative, the direction of u, which is also basically in the direction of v. I mean, you can write it in the direction of v if you wanted to, but I just want to write it in the direction of u because it's the same thing. U is also in the direction of v, so it's the same thing. As long as you get the answer correct. So that's equal to the gradient dot with the unit vector. So this at the point, what's the point? 0, pi over 3 is the gradient at 0, pi over 3 dot with the unit vector, which is, I'll just write it like that for now, and then we can, in the next step, write it all out. So the gradient ends up being 7 root 3 over 2, comma 7 halves, dot negative 3/5, comma 4/5. So it's 7 root 3 over 2 times negative 3/5 plus 7 halves times 4/5. Okay, so we have 1, we have 2, negative 21 root 3 over 10 plus 14/5, which is, of course, 28/10, which is negative 21 root 3. I'll write it like this. 28 minus 21 root 3 over 10. We can try to factor out like a 7, something like that. We don't really have to, because again, it won't really be divisible by 10, I think, so it's not gonna be useful. So this is your directional derivative.